Problem 114, chapter 5. We have this spool which is moving downward, and um, this ring or cable which is wrapped around this spool is connected to the roof from one side of it. So when the spool is coming down, it's going to rotate as well. At this moment, it is saying the velocity of the center of the spool is v naught, which is 2 meters per second. And also, it says the acceleration of it is 5 meters per second square as well. So the center of the disk has acceleration, which is equal to 5 meters per second square. And the velocity of it is 2 meters per second. And it is asking what is the what is the acceleration of point A, point P, and also point B. Okay, I would say spend like 15 minutes on this. Do your best. And I would say first try to find omega and then alpha of the spool. After finding omega and alpha of it, then you should be able to find acceleration of any points on the spool by using relative acceleration equation between that point and the center of the pulley. Okay, assume you did that. So we know the velocity of the center of this pulley is 2 meters per second. If you remember, we proved whenever you have a pulley which is rolling on the ground without any slip, the velocity of the center is going to be r times omega. It is the same problem. Just if you turn this 90 degrees, it's going to be the same thing, right? It is a pulley which is rotating without any slip on this ground, right? Just look at the smaller circle. So in that condition, we prove the velocity is going to be r times omega. And because we know the velocity, we know the radius, we should be able to find omega. Same thing for acceleration. We proved acceleration of the center is going to be r times alpha of the roller, right? So we have the same velocity of it, angular velocity of it. It is in counterclockwise direction. And same thing, I'm assuming alpha is in the counterclockwise direction too, right? Velocity of O, the equation was this. Velocity of the center is equal to r times omega. And from here, omega is going to be VO divided by r. VO is 2, and the radius, the smaller radius, is 0.48. So divided by 0.48, omega will be 4.17 radian per second. And also we have this equation too for no slip rolling disk. Acceleration of the center is equal to r times alpha. So here we know what is acceleration, we know what is r, so we are going to be able to find alpha. Alpha is going to be equal to acceleration, which is 5, divided by radius, which is 0.48. So it's going to be equal to 10.42 radian per second square. And both of them are in counterclockwise direction, right? So we found angular velocity and angular acceleration of this spool. So now we can easily find acceleration of any other points on this pulley. For example, acceleration of A, if I want to find it, acceleration of A is going to be equal to acceleration of O plus alpha cross OA minus omega squared times OA, right? We can do the same thing for other points too. So because we know everything in the right side of this equation, we should be able to find acceleration of A. Acceleration of O is 5 downward in the j direction, so negative 5j. Alpha, we found it to be 10.42, so 10.42. It is in counterclockwise direction, so k hat, positive k, cross OA, and OA is negative 0.48 in the I direction. Minus omega squared minus 4.17 squared times OA, again negative 40.48 I hat, which is quite easy. The only thing we have here is a cross product. K cross I is J. So do that math. Acceleration of A should be equal to 8.33 I hat minus 10 J hat meter per second square. Okay. We can do exactly the same thing for point B and also for point P. Just write down the relative acceleration equation between any of these points and point O, and the right side of that equation is going to be known. Everything is known, right? That's all.